Hi everyone, this is Shruti Pandey from the Department of Chemical Engineering at IIT Kanpur, and I welcome you all to the lecture number 3 of alcohols, phenols and ethers in chemistry of class 12th. So in the previous lecture, we discussed about the nomenclature of the alcohols, phenols and ethers separately, and we talked about the rules and the conventions which were pertaining to the common names as well as the IUPAC names of all these three compounds, three classes of compounds separately. Okay. And after that, we also did a lot of examples with different kinds of groups. So now today we are going to start with the structures of functional groups. That is, we will understand about the structure of these compounds at the molecular level. Matlab, what is the bond length, what is the bond angle, what is the hybridization state, you know, all these things we are going to discuss today. So let's start structures. Okay, at the molecular level. So first I am going to draw the structure of one alcohol, one phenol and one ether. And I'll choose the simplest of all these compounds just to be just to save time in drawing. So I'm drawing methanol first and I'll specify the molecular details in the diagram. Okay? This is CH3, this is O, this is H, and these are the two lone pairs of at O. Now, this bond length is 96 pm, 96 picometers. Picometers is 10 to the power minus 12 meters. Okay, I'll use a different ink for properties. Okay, just to, so this bond length is 96 picometers, 10 to the power minus 12 meters. This bond length is 142 picometers, and this bond angle is 108.9 degrees. Okay. Now coming to a phenol. So here what happens is this is O. These are the lone pairs and this is H. Now coming to the simplest ether, I am choosing dimethyl ether for this purpose. In this case, this bond angle between O and H is 109 degrees and this bond length is 136 picometers. And the OH and the bond length between O and H will remain the same as in the previous case, that was 96 picometers. Here you will see that this angle between these two compounds is 111.7 degrees, while this bond length in both the cases, like in for both of the methyl groups, it will be 141 picometer. Okay. So this is alcohol in general. This is phenol and this is ether. Fine. Now we are going to talk about this. Now, for the case of alcohols, the COH bond is a sigma bond. मतलब ये जो C और O वाला bond है, that is 142 picometers, that is a sigma bond which is formed by the overlap of sp3 hybridized orbital of the carbon with the sp3 hybridized orbital of oxygen. ठीक है, तो दोनों के ही sp3 hybridized orbitals आपस में overlap करती हैं and then they form a sigma bond. ठीक है, ये तो वैसे भी पता होना चाहिए आप लोगों को कि सिग्मा बॉन्ड का फॉर्मेशन कैसे होता है. And the bond angle in this case is you can see that this is 108.9 degrees. Okay, now let me first tell you about the tetrahedral geometry. See, what happens is when suppose this is some atom. Okay, let's take it C only because C has uh, like C can attach 4 groups. ठीक है. So one geometry is tetrahedral geometry, which is also composed of 4 groups around an atom. Okay, so when there are 4 groups attached to an atom, they are uh, they are in a tetrahedral geometry, and the angle between those the bond angle between any two groups, that will be 109 degrees and 28 minutes. तो मतलब जैसे अगर हम C की बात करें तो if फोर ग्रुप्स कोई भी हम ले लेते हैं, कोई भी नहीं, दे शुड बी सेम, तो हम लोग H लेते हैं, CH4। ठीक है, क्योंकि अगर हम बड़ा लाइक इफ विल टेक अ बिगर ग्रुप, देन ड्यू टू स्टेरिक हिंड्रेंस एंड द इलेक्ट्रॉनिक रिपल्शन, ये जो एंगल होता है ना, ये चेंज हो जाता है। ठीक है, तो वी आर गोइंग टू टेक द सिंपलेस्ट मॉलिक्यूल, दैट इज CH4। एक ऐसे, और बाकी जो ये एक प्लेन में नहीं है, ठीक है, तो इसलिए आपको दिखेगा नहीं उस तरीके से, बट दिस इज द tetrahedral geometry in 3D also. You can google it in the 3D view, so you'll be able to see it properly। तो ऐसा होता है tetrahedral geometry, और इसमें सारे जो ये एंगल्स होते हैं ना, these all are कितना, 109 degrees and 28 minutes। ठीक है, सो नाउ अब यहाँ पे भी देखो ऐसा ही केस है, यहाँ पे कार्बन नहीं है, यहाँ पे वी आर टॉकिंग अबाउट द OH हाइड्रोक्सी ग्रुप। ठीक है, तो इफ वी लुक अबाउट द ऑक्सीजन एटम, तो हियर द डिफरेंस इज कि ऑक्सीजन एटम हैज टू बॉन्ड्स एंड टू लोन पेयर्स। ठीक है, तो मान लो ये ऑक्सीजन है, इसके पास भी, आई मीन इन द केस ऑफ कार्बन ऑल्सो, in methane and CH4 also, there were four pairs of electrons, but all these pairs of electrons, they were in the form of bonds। ठीक है, बॉन्ड बना रहे थे। ठीक है, in the case of oxygen, there are four pairs of electrons, but the difference is two are in the form of bonds and two are in the form of lone pairs on on oxygen atom। ठीक है, so there are, because there are four pairs of electrons, the geometry around the oxygen atom should also be tetrahedral, right? मतलब ज्योमेट्री तो ऐसे ही होनी चाहिए ना, क्योंकि इलेक्ट्रॉन्स तो वैसे ही स्ट्रक्चर में प्रेजेंट है, पेयर्स ऑफ इलेक्ट्रॉन्स उतने ही हैं, तो ज्योमेट्री भी उसी से कंपैरेबल होनी चाहिए, टेट्राहेड्रल से ही। नाउ यू कैन सी कि जो एंगल है, बॉन्ड एंगल अराउंड O, that is 108.9 degrees, that is approximately equal to the tetrahedral geometry bond angle, that is 109 degrees and 28 minutes, but it is slightly less than this. And what is the reason that it is less? Because of the repulsion between the unshared electron pairs of oxygen. You can see here that I have made the electron pairs on the oxygen atom। तो वो क्या करते हैं, वो दोनों, इन दोनों, ये जो दोनों बॉन्ड्स है, CO बॉन्ड और जो OH बॉन्ड है, मतलब ये वाला बॉन्ड जो CO बॉन्ड है और ये वाला जो OH बॉन्ड है, इन दोनों को रिपेल करते हैं, तो ये दोनों जो बॉन्ड्स हैं ये आपस में क्लोज आ जाते हैं, दे कम क्लोजर टू ईच अदर than the ideal tetrahedral geometry angle, and इस वजह से this angle is less than the 109 degrees। ठीक है, so it is because of the repulsion, तो कम है because of the repulsion between unshared, or you can say the lone electron pairs। Now, in phenols, what happened? The OH group is attached to the sp2 hybridized carbon of the aromatic ring। ठीक है, ये वाला जो कार्बन है, ये क्योंकि ये that is a part of a double bond, इस वजह से ये sp2 hybridized है। ठीक है, talking about the bond length, the bond length in phenols, the CO bond length we are talking about, not about OH। देखो OH की जो bond length होगी वो तो सब में सेम ही रहेगी, because O भी सेम है, मतलब the properties of O and H, they are all almost the same, right, everywhere। So OH bond length will be same in all the three cases। We are talking about the CO bond length। ठीक है, CO bond length जो है in phenol, जो CO bond length है in phenol is less than CO bond length in methanol। दिस यू कैन सी, मिथेनॉल में कितना है, 142 पिकोमीटर्स है, और फिनॉल में इट इज 136 पिकोमीटर्स। तो व्हाई इज दिस बॉन्ड लेंथ लेस? So there are two reasons for this. First is because of the partial double bond character due to the conjugation of lone pair of electrons on the oxygen atom. And why does this happen? Because of resonance. So I had drawn, okay, so I'm drawing the resonance structure. Suppose this is OH, this is the lone pairs, ठीक है, और ये फिनॉल है, बेंजीन रिंग है, ठीक है. तो आपको पता है रेजोनेंस में क्या होता है कि वन ऑफ द लोन पेयर, इफ द लोन पेयर इज प्रेजेंट ऑन द सब्स्टिट्यूएंट और द फंक्शनल ग्रुप, then this lone pair will go here and this double bond electrons or the pi electrons will come here. So our next structure or the next we can say the hybrid structure would be एक lone pair तो रहेगा, यहाँ डबल बॉन्ड आ जाएगा, ठीक है, और दिस डबल बॉन्ड विल द इलेक्ट्रॉन्स विल बी हियर और बाकी विल रिमेन सेम, ठीक है. Now in the next structure what will happen? These electrons will come here and these double bond or the pi electrons will go over here. ठीक है. And then one more structure will be there that you can draw it yourself. I'm just what I want to say is you can see in these structures that there is a double bond in the resonance structures. In the hybrid structures there is a double bond between the OH and the carbon atom. So because actual में double bond नहीं होता है, that is only in the hybrid structures. That is why we say that this is a partial double bond character. ठीक है, एक्चुअल में तो डबल बॉन्ड नहीं है ना, जो हमारा ओवरऑल स्ट्रक्चर है that doesn't have a double bond. ठीक है, तो that is why we call it a partial double bond character. And you know that double bond in the case of double bonds the bond length is less than in the case of single bond. Single bond is always longer, ठीक है, and it is weaker as compared to double bond. Double bonds they are shorter and they are stronger. कि डबल बॉन्ड है, पाई इलेक्ट्रॉन्स भी इन्वॉल्व है, इस वजह से इट इज स्ट्रोंगर एंड शॉर्टर. So this is one of the reason why the CO bond length in phenol is less. Now another reason is because of the sp2 hybridization of carbon atom. Because carbon atom के पास like it is a part of a double bond, right? हाँ. So this carbon atom is sp2 hybridized. It is a part of a double bond. This is also one of the reasons why the bond length is less. So this was about the bond length in the case of phenol and methanol. Now coming to ethers. In ethers, also there are four electron pairs are arranged in a tetrahedral fashion. ठीक है, जैसे अभी मैंने बताया इस केस में भी दो bonds हैं और दो lone pairs हैं. The bond angle you can see it is 111.7 degrees, which is slightly more than the ideal bond angle of the tetrahedral geometry. वो कितना होता है 109.28 degrees. ठीक है. And why this angle is more? Because of the repulsion between the two bulky groups. देखो पहले अल्कोहल के केस में क्या हो रहा था, the repulsion was क्योंकि CH3 and H is smaller, ठीक है, H is a very small atom, ठीक है, तो ये अपने आप में इतना रिपल्शन नहीं देता है, रिपल्शन या फिर बहुत ज्यादा फोर्सेस ऑफ इंटरेक्शन नहीं देता है, लेकिन उस केस में लोन पेयर्स ऑफ इलेक्ट्रॉन्स दे वर forcing the bond angle to be less. In the case of ether it's just the opposite is happening because CH3 and CH3 both are bulky groups, ठीक है, so both of these groups they are forcing the bond angle to be larger than the actual geometry. ठीक है, बिकॉज लोन पेयर्स तो एक पेयर ऑफ इलेक्ट्रॉन है सिंपली, है ना, सो उनका इतना रिपल्शन ज्यादा उनका इतना ज्यादा रिपल्शन नहीं है एज कंपेयर टू बोथ द मिथाइल ग्रुप्स. इस वजह से जस्ट द ऑपोजिट इज हैपनिंग इन द केस ऑफ ईथर एंड द बॉन्ड एंगल इज मोर एज कंपेयर टू द आइडियल वन. ठीक है, एंड टॉकिंग अबाउट द बॉन्ड लेंथ यू कैन सी इट इज ऑलमोस्ट सिमिलर एज इन द केस ऑफ अल्कोहल. तो बॉन्ड लेंथ में ज्यादा फर्क नहीं पड़ता. इट इज 141 हियर and 142 in the case of alcohol. So this was all about the structure of these three compounds. at the molecular level. Now we are going to start the preparation of alcohols. Okay. So we come to the preparation of alcohols. So we will be going to study three routes. Yes, sir, you can say three types of reacting compounds from which we can manufacture alcohols. The ways are more. Okay. The ways are more. Talking about the reactants, we have three reactants that we are going to study. And what are these? First, from the alkenes. How can we prepare alcohols using alkenes? Then from carbonyl compounds. Carbonyl compounds, we will be talking about the aldehydes and the ketones. And from Grignard reagent. In the third case, I'll first tell you that what are actually Grignard reagents, how are they formed, how are they prepared, and then I'll go on with the preparation from Grignard reagent. Okay. So these are the three reagents which can be used to form alcohols. Now, from alkenes, first we are going to start the preparation from alkenes. Now, this is subdivided into two parts. I mean, the alkenes can be used in two ways to prepare alcohols. So, the first one is by acid catalyzed hydration. Hydration matlab reaction with water, or acid catalyzed matlab in the presence of acid. The reaction with water in the presence of acid. And the second one is the hydroboration oxidation. So this will be a completely new technique for you all, because this is the first time we are going through this hydroboration oxidation. Okay. So okay, let's start with this, with the first technique, which is acid catalyzed hydration. Okay. So first I am going to write down the a general reaction. Okay, so alkenes, they react with water in presence of an acid as a catalyst to form alcohol. ठीक है, ये water है. Now this is a kind of reversible reaction, and acid here H plus is denotes acid. ठीक है, what are acids? Acids are all those compounds which are capable of donating a proton. Proton मतलब H plus. They are capable of donating proton very easily. ठीक है, तो इस उन्हीं compounds को acid बोलते हैं. And what are we getting? One carbon will get H and the another carbon will get OH. So this is the alkene and this is alcohol. Now I'm using the simplest alkane, that is propene, here to write the reaction. Okay, so this is the reaction, and now you can see here that the alkene that we have taken is unsymmetrical or asymmetrical. That means the groups that are attached on the both the sides of the double bond, they are not same, they are different. एक तरफ CH2 लगा हुआ है और एक तरफ CH3 लगा हुआ है. ठीक है, that means in the case of unsymmetrical alkenes we will follow the Markovnikov's rule. ठीक है, I had already discussed the Markovnikov's rule during the haloalkanes and haloarenes chapter, but I'll again revise it. So what does Markovnikov's rule say? It says that when a protic acid is added to an asymmetrical alkene, जैसा यहाँ पे है, the acidic hydrogen attaches itself to the carbon which is having greater number of hydrogen atoms. Whereas the other group. It adds to the carbon with the less number of hydrogen atoms. मतलब हाइड्रोजन अटैच होगा उस कार्बन से जहाँ पे ऑलरेडी ज्यादा हाइड्रोजन है. ठीक है. Because you can memorize it ki hydrogen, all the hydrogens they are friends, and because one carbon atom it has more number of hydrogen, so the hydrogen will want to go to the place where it has more of its friends. ठीक है, more of its friends or more of its relatives. So this was the Markovnikov's rule. ठीक है, तो यहाँ पे भी हमने Markovnikov's rule ही अप्लाई किया है. देखिए ये वाला the first carbon it has two number of hydrogens and the second carbon has one hydrogen. So so जो ये H plus होगा that will get attached to the which has more number of hydrogen atom, that is first carbon. और जो OH होगा it will get attached to the second carbon. So I am writing down the name here. This is the Markovnikov's rule. ठीक. Now we are going to this was a general overall reaction. ठीक है. Now we are going to understand the mechanism of this reaction in detail कि ये reaction पूरी तरीके से कैसे होता है, back end में क्या क्या हो रहा है. ठीक है. So the first step in this is protonation of alkene. प्रोटोनेशन किससे होगा? प्रोटॉन से. जो H प्लस है एसिड ने प्रोटॉन दिया and वही that will be responsible for the protonation of alkene to form carbocation. ठीक है. And in other words we can call it as electrophilic attack of H3O plus. I will explain you this. I'm just writing attack of H3O plus, that is a hydronium ion. So first of all what happens is ये जो H2O है and this H plus they form H3O plus. अब ऐसा क्यों होता है? Because see water hydronium ion is a very good acid. I mean it is a very good acid. It can give the H plus very easily. ठीक है, as compared to water and the other acid that you are using. So that is why water will react with this, will take this H plus or the proton and it will form the hydronium ion. ठीक है. अब ये हाइड्रोनियम आयन क्या करेगा? इट विल प्रोटोनेट द एल्कीन. मतलब अगर हम जनरल रिएक्शन लिखें तो ये एल्कीन है व्हेन दिस रिएक्ट्स विद द हाइड्रोनियम आयन. अब हाइड्रोनियम आयन का स्ट्रक्चर कैसा होता है? देखो, दिस इज वन एच, दिस इज वन एच, दिस इज वन एच, एंड बिकॉज एक लोन पेयर जा चुका है that is used up for bonding, so that is why it is यहाँ पे प्लस आ जाएगा. So this is the hydronium ion H3O plus. Now when this reacts, what do we get? We get this C, one H will come here and this will be a carbocation. ठीक है. तो क्या हुआ कि the double bond has gone, मतलब the unsaturation has been removed and this H plus, ये जो हाइड्रोनियम आयन है ना ये H प्लस दे देगा. आई टोल्ड यू कि हाइड्रोनियम आयन इज अ वेरी गुड एसिड एंड इट गिव्स ऑफ H प्लस आयन्स वेरी इजीली. ठीक है. तो ये इसने H प्लस दिया एंड इट हैज प्रोटोनेटेड दिस एल्कीन. तो एक कार्बन पे जाके H लग गया और एक कार्बन पे जाके प्लस. मतलब नॉट लग गया, आई एम जस्ट द वे ऑफ यू कैन मेमोराइज इट दिस वे, but it's a carbocation has been formed because only three bonds are there. So there is a loss of electrons and that is why there is a plus charge on this carbon atom. क्योंकि चार bond होते तो stable होता. Because only three bonds are there, so we have got loss of electrons plus charge. ठीक है. So this is a protonated alkene and क्योंकि हाइड्रोनियम आयन से H plus जा चुका है, so we get water over here. ठीक है. This was the first step. Now the second step says is the nucleophilic attack of water on carbocation. ठीक है, अब ये जो हमारा कार्बोकेटाइन यहाँ पे बना है ऐसा, ये इट विल अगेन रिएक्ट विद वाटर, लेकिन अभी क्या होगा, पहले हाइड्रोनियम आयन से रिएक्ट किया था एल्कीन, ठीक है, सो दैट वाज बिकॉज इट वांटेड टू गेट प्रोटोनेटेड, ठीक है। अभी यहाँ पे जो वाटर रिएक्ट कर रहा है विद दिस कार्बोकेटाइन, इट इज रिएक्टिंग एज अ न्यूक्लियोफाइल। न्यूक्लियोफाइल क्या करता है, H प्लस, जैसे वाटर, व्हाट इज वाटर, इट इज H प्लस प्लस OH माइनस, ठीक है। तो इट विल गेट nucleophilic attack is like when Nu minus is reacting, when the molecule it has more number of electrons and it wants a place which has less number of electrons, ठीक है। न्यूक्लियोफाइल जो होता है वो नेगेटिवली चार्ज होता है, ठीक है, मतलब ये ऐसा होता है Nu माइनस, इसके पास मोर नंबर ऑफ इलेक्ट्रॉन्स है, एंड वो तभी अटैक करता है व्हेन इट गेट्स अ प्लेस वेयर देयर इज अ शॉर्टेज ऑफ इलेक्ट्रॉन्स, जैसे कि अभी कार्बन के पास है, ठीक है, कार्बन के पास प्लस चार्ज है ना, so nucleophile will come and attack this carbon atom. तो रिजल्ट क्या होगा, this is also a reversible step because carbocation is involved here. यहाँ पे 3 H लगे, mean these are the groups, this is H जो अभी add हुआ था, these are 2 other groups and water has been added here through O. ऑक्सीजन जो है वो कार्बन के साथ बॉन्ड बनाया है and there is a plus charge over here, ठीक है। Now step 3 says deprotonation to give alcohol, ठीक है। तो अब क्या होगा, ये वाला जो कंपाउंड है इन द स्टेप नंबर 3, इट विल अगेन रिएक्ट विद वाटर। नाउ व्हाट विल हैपन इज, वाटर क्या करेगा, फिर से H प्लस ले लेगा इससे, ठीक है, H प्लस इससे ले लेगा और वापस में सिर्फ अल्कोहल बच जाएगा, कैसे, लेट्स सी, दिस इज द H and H plus has gone to water, so again H3O plus has been formed, ठीक है। तो ये स्टेप नंबर 3 था। तो पहले क्या हुआ, पहले एल्कीन का प्रोटोनेशन हुआ, द प्रोटोनेशन ऑफ एल्कीन एंड कार्बोकेटाइन हैज बीन फॉर्म्ड यूजिंग हाइड्रोनियम आयन, ठीक है। नाउ देयर इज अ न्यूक्लियोफिलिक अटैक ऑफ वाटर ऑन कार्बोकेटाइन, so water is acting as a nucleophile because it is reacting with the carbocation, that is plus charged molecule. Then we will get this compound and it will again react with water to deprotonate this compound and form alcohol. So these are the 3 steps which are involved or they are happening at the back end for this overall step. This is first I have written the overall step, ठीक है। तो this was all about the first method to prepare alcohols. Now we are coming to the second method, and that is the very new to all because this is the method that is used only here. I mean, it is not used anywhere else. So the second method using alkenes, it is hydroboration oxidation. Okay. Now see, this B is boron. Okay, it's an element. When this BH3 is a compound which is borane, which is known as borane, ठीक है। और जब हम इसको इसके 2 मॉलिक्यूल्स ले लेते हैं तो ये क्या हो जाता है, डाइबोरेन, ठीक है। सो दिस इज द रिएजेंट in this process, this will be the reagent, that is diborane. So first I'll write down the overall reaction for the general alkene. So this is the general alkene, plus we are reacting it with diborane, this, and in this we also need to use 2 other reagents जिनका अभी यूज मैं बताऊंगी आगे, when I'll do the mechanism with you all. NaOH and that too aqueous. ठीक है, aqueous होना जरूरी है. Now what we will get is दो ग्रुप्स यहाँ पे, दो ग्रुप्स यहाँ पे, and H and OH. So this is the alcohol. ठीक है, देखने में जो प्रोडक्ट है that is similar as we had done in the previous case, but actually the product is not similar. I'll tell you why and what is the difference between the first and the second method also. So first we'll do the mechanism. Here also two steps are involved. The first step, step 1 says diborane reacts with the alkenes to give trialkyl borane. Trialkyl borane. ठीक है, so this will be a little complicated mechanism as compared to the first one. So I will be writing this. Here also we are first taking the simplest alkene. ठीक है, so this is our propene, and what happens is ये मेरा ये BH3 ही है. ठीक है, this is BH2. We have written it this way. This is diborane, and when it adds, so ये मैंने H इसलिए इस तरीके से लिखा है diborane. I simply want to tell कि this bond will break and H and BH2 they will get added to the both the sides of the double bond. मतलब they will get attached to the carbon atoms which are part of the double bond. ठीक है, तो ये एक तरफ BH2 चला जाएगा और एक तरफ H चला जाएगा. So this is a simple addition reaction. ठीक है, इसमें कुछ पीछे नहीं हो रहा है, simply ये वाला बॉन्ड ब्रेक हो रहा है BH2 and H वाला, एंड द एडिशन इज हैपनिंग. तो प्रोडक्ट क्या होगा, ये. ठीक है, नाउ अगेन ये अभी रिएक्शन यहाँ पे रुकता नहीं है. ठीक है, बिकॉज बिकॉज बोरेन डाइबोरेन हैज स्टिल द हाइड्रोजन एटम्स लेफ्ट. अभी भी उसके पास हाइड्रोजन एटम्स हैं. सो अभी भी ये रिएक्शन रुकेगा नहीं. इट विल गो ऑन and it will take one more molecule of alkene. It will again react with one other molecule of alkene and the product will be BH. ठीक है, तो अब क्या हो गया, when it reacts with one more alkene तो एक और H replace हो गया. ठीक है, one more H has been replaced with this other alkene molecule. Now this borane, it has one more H which is left, so again it will react with one more alkene molecule. If here यहाँ पे तो propene है, so it will react with one more propene and the final product will be this thrice B. ठीक है, तो बेसिकली क्या हो रहा है, ऐसे समझो, जैसे ये बोरेन है एंड ये H3 BH3. ठीक है, डाइबोरेन. तो बोरेन में क्या हो रहा है, ये ऐसा है BH3. सो व्हेन इट रिएक्ट्स विद वन एल्कीन मॉलिक्यूल, ये वाला बॉन्ड ब्रेक हुआ और यहाँ पे H की जगह पे एल्कीन लग गया. ठीक है, ठीक है, अब क्या हुआ, बिकॉज इट हैज अदर H एटम्स स्टिल रिमेनिंग विद इट, सो वन मोर एल्कीन मॉलिक्यूल will come, it will react with another molecule and ये वाला बॉन्ड भी ब्रेक हो जाएगा और फिर ये वाला जो H होगा ना उसको भी रिप्लेस कर देगा एल्कीन से. ठीक है, फिर it will react with the third alkene molecule and break this bond and again one alkene will be replaced here. ठीक है, तो जो फाइनल स्ट्रक्चर है वो ऐसे ही है, ये B है और we have three alkyl groups which are attached to this boron. ठीक है, तो वही चीज यहाँ पे हुई है कि हाइड्रोजन की जगह पे, तीन हाइड्रोजन की जगह पे तीन एल्कीन मॉलिक्यूल्स लग गए हैं, alkyl groups, and that is why this product is known as trialkyl borane. ठीक है, I wrote it here, I have written it here that this is trialkyl borane, जो कि ऐसा है. ठीक है. Okay, now coming to the step number 2. Step number 2 says this trialkyl borane, it is oxidized. So this is the oxidation step. ठीक है. Oxidation by H2O2. So you must be aware, or if you are not, then uh, this H2O2, that is hydrogen peroxide, it is a very good oxidizing agent. ठीक है. I mean, it is used in variety of applications, variety of reactions where you have to oxidize the reagent. ठीक है. कोई भी reagent को अगर आपको ऑर्गेनिक केमिस्ट्री में ऑक्सीडाइज करवाना है, then you can simply use हाइड्रोजन पेरोक्साइड and it will give you the result. So यहाँ पे भी हम H2O2 को as oxidation as an oxidizing agent use कर रहे हैं, but in the presence of NOH aqueous. ठीक है. तो बाकी दो reagent मैंने overall reaction में लिखे थे, that was H2O2 and NOH. Apart from diborane, they are being used in the second step. ठीक है. तो हम कैसे लिखेंगे? This is the first step का product, trialkyl borane. When this will react with NaOH in presence of NaOH aqueous, and this is H2O2 as an oxidizing agent. ठीक है. मैं यहाँ पे लिख रही हूँ कि what is the role of this reagent. Fine. So now what we will get is, we will get और वो इसको ऑक्सीडाइज कर देगा. The OH will get attached to this. क्योंकि we had 3 alkyl groups over here. यहाँ पे 3 है ना, 3. तो 3 alkyl groups है, इस वजह से 3 मॉलिक्यूल बनेंगे अल्कोहल के. ठीक है. Because 3 molecules of alkene, they have already reacted in the first step. So therefore we will get the 3 molecules of alcohol as a final product. So so these are the 2 steps which are involved for this case. ठीक है. Now one thing to notice here is that the alcohol which is formed through this mechanism, it looks as if it has been formed by applying the anti-Markovnikov's rule. ठीक है. मतलब अभी I told you about the Markovnikov's rule. Now the anti-Markovnikov's rule is simply just the opposite uh, uh, of the Markovnikov. And what does it say? Markovnikov में क्या होता है कि the hydrogen is getting attached to the carbon which has more number of hydrogen atoms. Here anti-Markovnikov में क्या होता है कि the hydrogen will get attached to the carbon which has less number of hydrogen atoms. ठीक है. तो यहाँ पे देखो alkene में the carbon number 2 has less number of hydrogen atoms और वहीं पे हाइड्रोजन ऐड हो रहा है. ठीक है. इसका मतलब है कि जो प्रोडक्ट हमें मिला है that is some kind of a anti-Markovnikov product. ठीक है. अब people say कि this H2O2 whenever you add H2O2 or the hydrogen peroxide in the reaction, हमेशा anti-Markovnikov rule ही लगता है. ठीक है. But in this case we cannot say exactly कि because of H2O2 anti-Markovnikov is happening, because यहाँ पे H2O2 का काम अलग है. ठीक है. यहाँ पे वो actually reaction में participate कर रहा है and it is a very good oxidizing agent. ठीक है. तो वो oxidization मतलब oxidation का काम कर रहा है. ठीक है. But again you have to be careful about this कि जो दोनों reaction के products हैं. ठीक है. क्योंकि both of the ways, the first one that was dehydration in the presence of acid, and the second one, dehydroboration oxidation. Both are using alkenes as the reagents or the reactants, but the products which are formed from both of these processes, from both of these methods, they are different. ठीक है. पहले वाले केस में Markovnikov product बनता है, and in the second case we get the anti-Markovnikov product. ठीक है. So just remember in the questions they will always ask you I mean they'll always give you the unsymmetrical alkene. तो आपको ये ध्यान रखना है कि whenever they are using which kind of method, उसी हिसाब से which kind of product you have to form. ठीक है. So these were 2 methods from which alkenes they can be used to prepare alcohols. Then the other methods are from the carbonyl compounds and the Grignard region. ठीक है. So next we will do that. So the second method was from carbonyl. The first was from alkene, right? ठीक है. तो यहाँ पे कार्बोनिल कंपाउंड्स वी आर रेफरिंग टू द एल्डिहाइड्स एंड कीटोन्स. ठीक है. तो इसमें भी देयर आर वेरियस मेथड्स. दिस इज आई मीन देयर आर वेरियस मेथड्स जैसे एल्केन्स में थे. सो द फर्स्ट वन इज रिडक्शन ऑफ एल्डिहाइड्स एंड कीटोन्स. ठीक है. तो एल्डिहाइड्स एंड कीटोन्स दे रिएक्ट विद हाइड्रोजन इन द प्रेजेंस ऑफ कैटलिस्ट. ठीक है. तो इसका मतलब इस केस में we always have to use a catalyst, and this method is known as catalytic hydrogenation क्योंकि हाइड्रोजनेशन हो रहा है in the presence of catalyst. Now catalyst used is generally finely divided metals होते हैं. Like platinum, which is Pt, palladium, which is Pd, और निकल Ni. ठीक है. ये तीन ही यूज होते हैं जनरली सब जगह हाइड्रोजनेशन के लिए, कैटालिटिक हाइड्रोजनेशन के लिए. ठीक है. तो okay, these are the catalyst. So I am going to write down the reaction. General reaction. This is a general aldehyde. मतलब R can be any group, and this is CHO. So RCHO. And when you will react this with hydrogen in presence of any of these metals, then you will get the product as RCH2OH. ठीक है. इसमें कुछ इसमें कुछ बहुत ज्यादा like there is nothing like a kind of mechanism which is involved here. It's simply कि जैसे ये CH और यहाँ पे डबल बॉन्ड O, दिस इज CHO एंड सिंपल हाइड्रोजनेशन हो रहे हैं. ठीक है. मतलब वन H is getting attached here and one H is getting attached here. मतलब एक कार्बन में और एक ऑक्सीजन में, and this thing is removing the double bond. ठीक है. So it's a very simple kind of mechanism and you can easily understand this. Now in the case of ketones, this will be RCO R prime. ठीक है. R and R prime, they can be same or they can be different. When these are reacted with hydrogen in presence of a metal, then we get RCH R prime and OH. ठीक है. इसमें भी वही हुआ है. यहाँ पे भी जो C डबल बॉन्ड होते हैं, यहाँ पे दो ग्रुप्स होते हैं. ठीक है. तो one H will get attached to here and one H here, and this unsaturation has gone. ठीक है. So this is the simplest way to understand this and to remember this. Now this was using the catalytic hydrogenation. ठीक है. इसमें भी we have another reagent that you can use, and that is sodium borohydride. और lithium, aluminium hydride, and the formula is LiAlH4. ठीक है. So any of these two you can use, either sodium borohydride or lithium aluminium hydride. I'm writing or, you don't have to use both. ठीक है. These both compounds, they are the excellent reducing agents. ठीक है. हम क्या करवा रहे हैं, हम रिडक्शन ही तो करवा रहे हैं एल्डिहाइड्स और कीटोन्स का. ठीक है. सो दीज आर द एक्सेलेंट रिड्यूसिंग एजेंट्स, एंड इस केस में वी डोंट नीड टू यूज बिकॉज वो खुद ही हाइड्रोजन प्रोवाइड करते हैं, सो वी डोंट नीड टू यूज द हाइड्रोजन. So similarly in this case also the reactions will be similar. यहाँ पे भी हाइड्रोजनेशन ही हो रहा है, but only the reagents are different. ठीक है। तो जब ये चीज आप लोग याद रखना कि हमेशा जब भी NaBH4 और LiH4 किसी भी रिएजेंट के साथ यूज होंगे ना, दे विल ऑलवेज एक्ट एज अ रिड्यूसिंग एजेंट। ठीक है। So this is the reaction, and similarly for the aldehydes. Now, one thing that you need to observe here is that in the case of aldehyde, when you are trying to reduce aldehyde, you will always get the primary alcohol, क्योंकि उधर साइड पे, दूसरे साइड पे दूसरा अल्काइल ग्रुप नहीं है। ठीक है। तो यू विल ऑलवेज गेट द प्राइमरी अल्कोहल बिकॉज दैट कार्बन इज द फर्स्ट कार्बन। ठीक है। और वहीं पे OH लगेगा, तो दैट मीन्स यू विल ऑलवेज गेट द प्राइमरी अल्कोहल, क्योंकि उससे कोई और ग्रुप नहीं लगा हुआ है। ठीक। एंड इन द केस ऑफ कीटोन्स, व्हेन यू आर ट्राइंग टू रिड्यूस द कीटोन्स, बिकॉज यू हैव टू ग्रुप्स, दैट इज R एंड R प्राइम ऑलरेडी अटैच्ड टू दिस कार्बन, इसी कार्बन पे OH भी लग जाएगा, मतलब जब प्रोडक्ट बनेगा दैट विल बी अल्कोहल, एंड दैट OH विल बी अटैच्ड टू दिस मिडिल कार्बन। ठीक है। यहाँ पे, सो दिस कार्बन इट इज अटैच्ड टू द टू मोर कार्बन, यहाँ वाला कार्बन और यहाँ वाला कार्बन। सो दिस इज अ सेकेंडरी अल्कोहल। ठीक है। तो यू हैव टू रिमेम्बर दिस, कि जब एल्डिहाइड्स का रिडक्शन करवाते हैं तो वी गेट 1 डिग्री अल्कोहल, और जब कीटोन्स का रिडक्शन करवाते हैं वी गेट 2 डिग्री अल्कोहल। ठीक है। So this was the first method using which we can through which we can use the carbonyl compounds to prepare the alcohol. Now in the next session we will complete all the methods. Okay. Also we will talk about the Grignard reagent, and we will try to complete all the methods and all the ways through which we can prepare alcohols, and then we'll move on to the physical properties of alcohols also in the next lecture. Okay, class, this was all for today. Thank you.